Hey everyone, this is number 3 from the 2018 exam. This is the no calculator section, and this is number 3B. So the stem of this question says the graph of the continuous function g, which is also the derivative of f, is shown above. The function g is piecewise linear from -5 to 3. And g of x equals 2 times the quantity x minus 4 squared from 3 to 6. So they are saying from -5 to 3, we have a function that's made up of linear line segments, And then from 3 to 6, the function switches over and is parabolic, and that equation is given. So part B asks us to evaluate the area under the curve from 1 to 6, or the area between the curve and the x-axis from 1 to 6 of the g function. So if we look at that area from 1 to 6, we would be starting here and stopping here. And the first question is that geometry will help us with part of this. So we're going to split the integrals and think about what part of this area geometry is going to help us find. And that would be the area from 1 to 3, because that area is represented by a square. When we continue and go from 3 to 6, that area is going to be different because we're working with the parabola and we don't have a geometric formula to give us that area. So we're going to split this integral into 2 pieces, first from 1 to 3 and second from 3 to 6. And the next question I have for you is to find that area from 1 to 3. And that area would be 4, because you have a square, a 2 by 2 square. Then for the area from 3 to 6, we are going to have to look at that g of x function, which is 2x minus 4 squared, and then your dx. So think about how to evaluate that integral. So the first thing I'm going to do is take this constant of 2 and just move it to the outside. So I have 2, and then the integral from 3 to 6, x minus 4 squared dx. And remember that in order to evaluate an integral, there's 2 ways to do that. The first way would be finding an antiderivative, and the second way would be to find the area between the curve and the x-axis. From 3 to 6, we are not able to find that area with geometry because it is a parabola, so we are going to have to use the antiderivative. So I am going to find the antiderivative, and those steps are that I am adding 1 to the exponent and then dividing by the new exponent. So that would be my antiderivative, and at the end of this video I'm going to show this with u substitution. You actually do not need u substitution because the derivative of what's in parentheses is just 1, but I will show this with u substitution at the end. So you are able to add 1 and divide by the new exponent. That constant of 2 is sitting out front. And then we would just be plugging in the numbers and subtracting. So we have 6 minus 4 cubed over 3 minus 3 minus 4 cubed over 3. So this 4 was just out front. And maybe I will put parentheses around this. The 6 and the 3 are just getting plugged into that antiderivative. So actually you could be done at this point, right? This is a free response question, so you could be done and stop at this point. For anyone that is wanting to simplify further, 6 minus 4 is 2 to the third over 3. And 3 minus 4 is -1 to the third over 3. If we look at the exponents first, we have 2 to the third is 8 over the 3, and then negative 1 to the third is negative 1 over 3. So this would become 16 over 3 plus 2 over 3. We can add these fractions because they are fractions with common denominators, so that would be 18 over 3. We like this because 18 over 3 is 6, and we end up with 10. That was a lot of work there at the end. So just as a reminder, you are allowed to leave in that form, as you know. So jumping over to the rubric, they are giving you a point if you knew to split the integral at 3. And that was the idea that you could find the area of the square from 1 to 3, and then you would need to use a different approach from 3 to 6 because of the parabola. So that was a point. The second point is if you knew the antiderivative of that g of x function. And the last point was getting the answer either of 10 or that very unsimplified form, which we circled here. And those are the 3 points. So you can feel free to stop the video here. And then if you are interested in evaluating that integral with u substitution, I'm going to show that now. Okay, so let me go back to this. So we had 1 to 3 g of x and 3 to 6 that g of x function. Just noticing they have a little different approach there with the antiderivative of 2. We saw this as a square and got that area as 4. All right, and then I'm going to take that constant of 2 and move it out like we did before, and then we have x minus 4 squared dx. So if you were seeing this as u substitution, you might have written u is x minus 4. The derivative of u with respect to x is 1. And then remember, we multiplied by dx on both sides to get du is 1 dx. Okay, thinking about these colors that I used to use. So 1 dx is what we're looking for in the problem. And that's there already. There's an imaginary 1 there. And then the x minus 4, that is your u value. So I'm going to write 4 plus 2. We have the yellow, x minus 4 is u being squared, and then 1 dx becomes du. I'm going to also take these upper and lower limits, which are x values right now, and convert them to u values. So if I plug in the 3 minus 4 is negative 1. If I plug in the 6 minus 4 is 2. So those are my new upper and lower limits. And then when I find that antiderivative, it's easier, right? You would add 1 and divide by the new. And then we're going from negative 1 to 2. So that antiderivative, add 1, divide by the new exponent, and then the upper and lower limits of negative 1 and 2, those are u values, and you are allowed to plug them in for u. So we have 2 to the third over 3 minus negative 1 to the third over 3. You are allowed to leave your answer like that. If you wanted to simplify, 2 to the third is 8, so that would be 8 over 3 minus negative 1 to the third is negative 1 over 3, so that would become positive. 8 over 3 and 1 over 3, those fractions have common denominators, so you could make that 9 over 3. 9 over 3 is the same as 3, so we have 4 plus 6, which is 10. So you get the same answer, and that was using u substitution. All right, that is it for this question, which was 3B from the 2018 exam.